हेलो। अब आ रही है। हाँ, मैं कह रहा था कि क्या ये Dr. Katariya is a reviewer of many international journals. Her field of research is nanomaterials, thin films, and superconductors. She has published more than 17 research papers in referred journals of high repute, having more than 250 citations. Presently, she is working on the project of Delphosite thin film funded by MP Council of Science and Technology, Bhopal. She had organized several academic events, which include national conference, workshop, faculty development program in various areas of science. Katariya is a lifetime member of Indian Association of Physics Teachers and Indian Laser Association as well. Currently, she is working as Associate Professor, Department of Physics, Shri Vaishnav Vidyapit Vishwavidyalaya, Indore. With this short brief, I request Dr. Nitu Katariya to start with her presentation. Thank you, ma'am.
Thank you very much, sir. Good morning to all of you. First of all, I thanks to organizers for giving me opportunity to interact with you all and present a talk here in this 1 week FDP program. Today I'm going to present that is a systematic approach to polymer characterization, a roadmap. Basically, what is there in this FDP, you have learned so many techniques of characterization, but when we start working that the first question, there are so many techniques available for each characterization, which we have to approach first. What is the conditions for our samples, what we have to do.
So sorry to disturb you. You can make your screen on presentation mode also, not in presenting mode.
Yeah, I have shared it the full screen.
You have shared only the PPT things. You must share the entire screen of your system, then you can show the full screen.
Yeah, okay.
So make it unshared and share the entire screen of your
entire screen. Okay.
Yes, it's visible. You can continue.
So my talk is basically intended to the research scholars who are newly approaches in the field and the students who are attending this workshop, or sorry, this faculty development program. So first of all, as a brief, that is what is a polymer. That a polymer you have all have studied in this last days. That polymer is a large molecule or a macromolecule, which essentially is a combination of many subunits in a different types of arrangement, just like that the linear or branched or cross-linked or network. So this is the arrangement of the polymer monomers in this to form the polymers. Now the families of polymer consist of two types, that is the thermosets and thermoplastics. Thermosets are that cannot be melted and thermoplastics are the polymers which can be melted. So the phenolics and epoxies comes under the category of thermosets, and that thermoplastics, we have that polyethylene, PET, nylon, polystyrene, polycarbonate, etc. are comes in the category of thermoplastics, which we basically deals with that. And these are two types. They are maybe the semi-crystalline or they may be the amorphous, having no structure. Now, when we work on the polymers, the first question comes, what do we need to know? So that is it. First is the chemical identity, that which polymer is this, what additives are present is there, and is there is any contamination over there. That means what we want to prepare is that exactly with purity our material has been prepared or not. That is the first characterization that we have to do for going to the further. Then the second comes that amount of crystallinity, optical properties, molecular weight distribution. How is that molecular weight is distribution among the chains of the polymer? Then the solution behavior, viscosity, flow or gel, That is very important for the application point of view. And the thermal behavior. And the thermal behavior, that is the glass transition, melt and decomposition temperature. So these are the required quantities that we need to know to for that part application, for going to the application part of the polymer. Now, how we'll find these quantities? So there are various techniques available for characterizing this. These are that if we want to know the chemical identity and structure, we have FTIR, that is Fourier transform infrared spectroscopy. We have Raman spectroscopy. We have nuclear magnetic resonance. We have XRD. And the same is for the molecular weight, viscometer or chromatography, molecular solution behavior, the same viscometer and rheometer. Thermal behavior can be measured, that we have differential scanning calorimetry, DMA, TMA, melt flow index. Mechanical properties and the morphology. We have various techniques are available for each of them. The question arises, what technique we have to use? What is useful for us? So first we'll go this chemical identity and structural part. That in chemical identity, if you want to first the polymer structure, whether this solid state structure for the thermoplastic, it may be amorphous or semi-crystalline. So if it is a amorphous or semi-crystalline, that we need to know, we can know with the help of X-ray diffraction technique. X-ray diffraction techniques let us know that whether our sample prepared is the amorphous or semi-crystalline, so that with the help of this, if it is a semi-crystalline, we can know about the packing friction, orientation, and the details about the crystallinity. The degree of crystallinity can be known with the help of the X-ray diffraction. Basically, most of the polymers are amorphous, so XRD is not as a basic choice for the characterization, and to work on the first, that is the FTIR, Fourier transform infrared spectroscopy. So what is in that infrared spectroscopy? How it gives us about the idea of the chemical identity. So infrared spectroscopy deals with the infrared region of the electromagnetic spectrum. Only in the region is the energy intense enough to excite the bonds in molecule to absorb energy. Molecule absorb frequency of light because they correspond to frequency of vibration of bond in the molecule. It is just like that in the range of the infrared that spectrum, that each molecule vibrates at different frequencies. Just like the dance, we can analog is with that everyone has the different likes of beats. So the same as the molecules, that vibrations have different frequencies. When that IR frequency is equals to their natural frequency of vibration, that molecule starts the vibration. That is the basic principle of the infrared spectroscopy. And when this vibrates, it takes the energy and that gives the transmission as decreases over there. There are vibrations of mainly of two types, that may be stretching vibrations or bending vibration. Stretching vibrations are again are of two types, that may be symmetrical or anti-symmetrical, and that the bending are of also of the different types, that is the scissoring or wagging or toggling, etc. So this gives us the basics about the chemical identity of that. So this FTIR can be used for the wide range of materials, can be quickly analyzed with the Fourier transform infrared spectroscopy. And there are four main sampling methods used in FTIR, that is transmission, attenuated total reflectance, diffuse reflectance, and specular reflectance. These techniques are used for the different sampling methods. We can use according to our sample, we can take any one of them. In all the cases, sample is exposed to a beam of IR energy, and this sample absorbs and transmits this IR energy in a way that is characteristics to its chemical structure. And the result of the spectrum that is specific for each compound. So these are the different types of FTIR. That is a transmission FTIR spectroscopy, that KBR palette containing the sample in between. drift spectroscopy. ATR is the basically majorly used technique for the FTIR. Now, this is the FTIR spectra for the various polymers, that is polyethylene, polypropylene, polystyrene, and polytetrafluoroethylene. What is there? It has the two reasons. This wave number, reason 4000 to 1450 centimeter inverse, that is this reason of the functional group reason. In this, the absorption is because of the presence of the functional group, and each functional group has a different frequency of vibration, that is in between the 1450 to the 4000 centimeter inverse. And that the next reason, second part of that 1450 to 450, somewhere it is reported up to 500, somewhere it is 450. That is the fingerprint reason, which gives the spatial identity of that each compound, that which compound is present over there. So there are two reasons. Basically, FTIR spectra is for organic compounds. It is the very important study, and the very first chemical identity structural technique is used. Now, the second is come of the Raman spectroscopy. Raman spectroscopy, in that what happens in FTIR, we take the molecules, take the energy and vibrates. That's the absorption we measure. Transmission of light, that after absorption we get, that was available. And then in Raman spectroscopy, we got that scattering. When the light incident on the molecule, then there are scatterings occurs, and due to that scattering, we get the Stokes or anti-Stokes Raman scattering and Rayleigh's scattering. When the wavelength of scattered radiation is greater than the wavelength of our incident radiation, we tell it that is the Stokes Raman spectroscopy. When it is equal, we call it the Rayleigh's scattering, and when it is less, we call it anti-Stokes Raman spectroscopy. These are the common functional chemical groups which gives us their signatures on this position. When if it is a carbon-carbon bond, it gives us the at frequency 1060 and 1127. That is the remark of the polyethylene. Highly is, it is, we got carbon-carbon bond 700 to 1260. That is the highly mixed in complex molecule. So with the reference of this, we can characterize, we can identify which compound is there, which bond is present over there, whether it is single bond, double bond, or a triple bond, or aromatic ring, what is the available. Now question comes, Raman or FTIR, or Raman and FTIR, क्या हमें दोनों करना है या हमें एक करना है? So this answer of this question is that if we want this basically for organic compounds, if we go, that is for the FTIR is the good, for the inorganic, and that if we want the in-depth analysis, that is the sensitivity of the Raman is more at than the FTIR. So that is depends on our sample or our material, at which reason we want to characterize it. Now the next comes, that is the for structural characterization, we have nuclear magnetic resonance spectroscopy. That nuclear magnetic, before going to this nuclear magnetic resonance spectroscopy, I'll just have that this electromagnetic spectrum. This the wavelength is increased, and then frequency is from left to right, increase from left to right, and this is the right to left, that frequency and the energy. Now what is there? If we talk about this UV visible range, that UV visible range, electronic transitions are available. If we work on the infrared rays, that we got the vibrational motion. If we go to the microwave going further, that is the rotational. And now the further, if we go in the region of radio frequency, then that comes of the nuclear magnetic resonance spectroscopy. So nuclear magnetic resonance spectroscopy works on the radio frequency. Now what is there in the NMR? Like this, the basic principle is NMR is that each particle or the electrons or photons, each nuclei has a charge, and many have the spin. All will have a spin. It's not possible, as that there's a combination of even and odd, so that the spin is there. So nuclei are charged, and if they have a spin, they are magnetic. And when we applied the external magnetic field, then on applying the external magnetic field and give the energy of the transition is equals to the energy of the radio waves. Then lower energy state, if the molecule is aligned with applied field, and if it is aligned opposite to the applied field, the energy is the higher energy state. So NMR spectroscopy is used for structural analysis, polymerization monitoring, molecular weight determination, polymer dynamics, and polymer characterization. In solution, it is used. Now, so in structural, we have the 4 techniques, that is the XRD, FTIR, Raman, and NMR. We choose with the precision of our sample and the what application purpose we are using. Now, the next is molecular weight determination. The determination of molecular weight of polymer can be carried out using 3 methods. That's the viscosity, osmotic pressure method, and light scattering method, that is the chromatograph. In the viscosity and that osmotic pressure, that is a rheometer, that is we use the property of the solution, that how it is changes with our sample, and that indirectly we will calculate the molecular weight through these viscous flow and rheological properties. And the chromatography, we'll got the molecular weight, but that GP LC and HPLC both are used as a chromatography, but basically chromatography method is preferred over the viscosity and osmic pressure method, but same time that is the depends upon the availability of the instrument and the method. Now, at the last, we'll go to the very important characterization, that is the thermal analysis of the polymer. That there are 4 techniques available for the thermal analysis, that is scanning calorimetry, thermogravimetric analysis TGA, thermomechanical analysis TMA, and dynamic mechanical analysis DM. First, the differential scanning calorimetry DSC. What DSC measures? So DSC measures the heat flow into or out of a sample as a function of temperature or time. So it is widely used to study the glass transition temperature, and thermal stability. So it is particularly useful in thermal polymer. That is the basic diagram of the temperature versus heat flow. So first there is a TG, and then go for the crystallization, melting, then cross-linking current, and the decomposition oxidation. So various materials have the different glass transition temperature or melting. So this is the very important tool to characterize the polymer. Now the second is thermogravimetric analysis. Thermogravimetric analysis TGA. This measures the change of weight of a sample as a function of a temperature or a time. So it is commonly used to investigate thermal decomposition, degradation, and stability of polymer. So when we want to go for the stability, so we have to do the thermogravimetric analysis, and it provides the information about the mass loss, decomposition temperature, and composition of the sample. This is the basic TGA curve for the temperature versus weight for PVC, PMMA, PTFE, and PI. Next goes to the thermomechanical analysis. Thermomechanical analysis measures the dimensional changes, that is the expansion or contraction of a sample as a function of temperature of time. So it is useful for studying the coefficient of thermal expansion. softening behavior, glass transition temperature, and mechanical properties of polymer with temperature changes. So TMA is suitable for analyzing the thermal mechanical behavior of the polymer. So these are three techniques. The next is DMA. DMA is dynamic mechanical analysis. So it measures the mechanical properties of a material as a function of temperature, frequency, or time under the application of a small oscillatory force, and it provides information about the viscoelastic behavior, storage modulus, loss modulus, damping properties, and glass transition temperature of polymer. It is often used to study the mechanical and dynamic property of polymers. And this is the idealized DMA plot against the temperature. That is the loss of molecules, storage molecules G versus temperature, glassy region, glass transition region, gel region. Please excuse us for a minute. Hello, sorry. So this is the 4 techniques which we did in the thermal analysis part. So it depends upon, again, in our application of our sample material, which technique we have to use, which information we require. Hello. Sir.
Ji ma'am, your voice is coming. You're audible.
So if you want the mechanical properties, we go the thermomechanical analysis. If you want the weight properties, we go for the thermogravimetric analysis. If you want the temperature related, that is melting or crystallized heat capacity, we go for the DSC. So this is the 4 techniques available for the thermal behavior. So in summary, that is the DSC is generally the most versatile technique for analyzing the thermal behavior of polymers, as it provides information about phase transition, crystallization, melting, and heat capacity. However, depending on your specific research objective, any of the other techniques may be more suitable for addressing certain object of the polymer's thermal behavior. So we have the major 3 parts of the characterization, that is the structural, thermal, and molecular weight we have considered in this talk. And that goes to the for morphological, we have already have studied that AFM, SAMTAM, that can be used for the characterization of the morphology of the material. So with this, I just thank you all, and a very happy learning.
Thank you, ma'am, for being in time. Very well in time. Can you hear me?
Yes, sir.
Okay.
Thank you very much, sir.
Thank you.
Actually, we basically face this issue always. In our early times of research, we see all are doing the same thing. Moreover, a very small line between this, all the characterization. So that line of difference, we should know, then only we can make our protocol for our sample characterization.
Very true. It's very true. Like the similar question I asked to Dr. Ram Adhikari also. Like if somebody is planning to take the image of their sample, then whether he or she should go for SEM or TEM or optical polarized microscope. This is usually happen because the materials on which we are working, that materials normally offer the common characteristics, and which characterization we should go is a big question for all freshers and all newcomers. But still, I am very thankful to you that you have finished the talk in time, because it's the last day and I don't want to puzzle the participants more. Already they were into the system for last 9 days. So thank you very much. Thank you. So I think now we should move toward the valedictory session. Chesta, you can start from your side. You can stop sharing her. Yeah, Chesta, continue.
The time has come to draw a curtain to our program. I, Chesta Kothari, on behalf of ipsacademy Jhabua, wish you a very good morning and a warm welcome to all of you to this valedictory session of this conference. As we come to the valedictory function, I now take this opportunity to welcome our esteemed dignitaries and participants of the conference present over here. Participants were very enthusiastic. I am thankful to all the participants for coming to attend the conference. I am sure that the participants must have benefited by attending the conference. Now I request Dr. Amit Saxena sir, Principal ipsacademy Jhabua, to summarize the FDP on polymer electrolytes and characterization technique.
Thank you, Chester. Thank you. And I'm highly thankful to all the participants, those who registered themselves for this FDP, and they made this FDP really a great success for us. Normally, conducting an FDP on online mode, and that too for a long time, sometimes become puzzled. So I'm thankful that they were regularly present. In general, our attendance was pretty good in all of the sessions. So as Chester has asked me to summarize this FDP, so we planned this FDP somewhere 1 month back, and meanwhile I requested and approached the different speakers worldwide. We got total 8 speakers for our FDP, where Dr. Abdul Karim Aruf from Malaya is one of the keynote speaker for our first day session, which was followed by Dr. Noor, Dr. Bhaskar Bhattacharya, Dr. Ram Adhikari. They all are experts in their area of research. They have proven their expertise in terms of their publications, citations, their research scholars also. These talks were further followed by Dr. Rahul, Dr. Katariya, Dr. Nitu, and Dr. Aditya. Maybe you heard Dr. Aditya day before, yesterday on lithium-ion batteries. Out of this all 8 days, we got one special invited guest, Dr. V. Ganeshan sir. I requested him to share something on SPM, scanning probe microscope system, and he also participated and given a wonderful talk on this area. Total 79 participants got registered in our FDP. Out of the 79, 20 were from the abroad, all globe. Like I got the registration out of this 20, registration from Malaysia, Nepal, Sri Lanka, South Korea, and Mexico. And they were also very actively participated in throughout the process. I must find some important areas which was shared by our speakers, like Dr. Abdul Karim Aruf has given very fabulous and basic information on impedance spectroscopy technique. He also marked out that when we are finding the pole plot or neck-post plot, then the two sides of your graph, the x and y axis, must be of same scale, so that the graph would become so uniform and we can find the bulk resistance, which is useful for finding the conductivity of our polymeric film. He pointed out this very well. And also he pointed out very important aspect that how we can choose the frequency range for our sample. At what range of frequency we are calculating this impedance area of our sample. Usually we are doing at the range of 100 to 10 to the power 5 or 10 to the power 6 hertz of frequency. But he's also pointed out that how we can reduce this frequency and can be somewhere between this range to get the good value of our value. Dr. Noor has also given a very fabulous and very fundamental talk on impedance spectroscopy, how we can characterize it, what are the importance of real imaginary part of impedance, and how we can get the things very informative out of this impedance spectroscopy. Although I am also working in the area of impedance spectroscopy, and I find so many important and informative things out of this. Also, Bhaskar Bhattacharya, no doubt, always a good speaker. He mentioned how the polymer electrolytes can be used as the solar application or electrochemical application. What is the efficiency of solar cells? What are the effects of working on the discourse side, like carbon nanotubes, graphite, graphene into the polymer matrix? Ram Adhikari, no doubt, is one of the very attractive speaker in this FDP. After his talk, so many speakers approached me about his number and his email ID. He given very basic information about SEM and TEM, how we can interpret the SEM image and TEM image, how we can find which area is having more dense or lesser denser area, how we can analyze how the bulk boundaries are in there, how to find the crystalline and amorphous region and size of particle also of SEM and TEM. Dr. Rahul and Dr. Aditya is given a very good all idea about ion conducting membrane and lithium-ion batteries, how we can use this area to overcome the limitations of lithium-ion batteries, what are the importance of sodium-ion batteries. And very interestingly, yesterday, Dr. Aditya mentioned that they achieved the 0.2 C of efficiency on sodium-ion batteries, and this is very remarkable in the present context, because now the people are moving toward the sodium-ion batteries from the lithium-ion batteries. And no doubt, sodium-ion batteries have so many advantages, but at the same time, it has a limitation of their power density and the size of the batteries when we are compiling them or when we are binding them. I'm very thankful to Dr. Katariya and Nitu, madam, to share their outcomes on the various characterization techniques which we can use. This today's talk is also very informative, very fundamental for those who are trying to move toward the polymeric materials, and if they want to characterize the polymeric materials to their application or to their level of analysis. Today's talk is very informative to them also. This is all about the conclusion, and I am thankful to all the participants, to the management of the IPS Academy, and to all the resource person of this FDP to being here and sharing their information. Now over to Chesta.
Thank you, sir. End of a story is the new beginning. On this note, let's conclude a remarkable, memorable, knowledgeable event. To express a word of appreciation and gratitude, I would like to invite Assistant Professor, IPS Academy Jhabua, Ms. Sakshi Parikh ma'am, for vote of thanks.
Yes, I think Sakshi is not joined because of any technical session problem. I could not see Sakshi in this list. Sakshi, can I have you joined this session, Sakshi? No, okay, no problem, no problem. Meanwhile, I would like to have some feedback from participant side also. Participants, you are requested to give your feedback on this. It will be very enthusiastic and motivating to us so that we can plan some other activities in the coming time. So if any participant want to share their feedbacks with us, any participant. Any of you want to share something with us on this FDP? Abhishek Bharadwaji, if you can hear us, can you say a few words on this? I don't know whether he's able to. Anyone? No. Okay. No problem. Sakshi ma'am, you can continue with the vote of thanks. Please unmute your mic. Please unmute your mic first.
A warm and a graceful morning to our honorable guest, Dr. Nitu Katariya, Management Committee, dear teachers, parents, my dear friends, and everyone gathered here. It's my privilege to propose a vote of thanks and acknowledge the contribution of those who worked really hard to make this event possible. I, Sakshi Parikh, on behalf of IPS Academy and the entire fraternity of the institution, extend my sincere thanks to the Almighty for making today's event a grand success. I extend a hearty vote of thanks to our guest, Dr. Nitu Katariya, who spared time from his busy schedule to grace the occasion. Today we had an opportunity to hear you. Your talk, and this will surely encourage us in all our future endeavors. Your thoughts have enlightened our minds and have shown us a new path. I also want to extend thanks to all the speakers who have enlightened. I also want to extend thanks to all the speakers who have entertained us with their important and worthy opinions. I want to appreciate their efforts for making the event informative for all of us. An event like this cannot happen overnight. The wheels started rolling weeks ago. It requires planning and a bird's eye for detail. We have been fortunate enough to be backed by a team of very proactive and dedicated staff. A special mention to our respected principal, Mr. Amit Saxena, sir, for being the catalyst that stimulated us to do our best. With a deep sense of appreciation, we thank our loving teachers for their untiring efforts. I would like to thank all the respective representatives who have blessed us with their presence. I am thankful to all the staff for their efforts. All the speakers have beautifully added to the glory of this event. I am gratified to all the audience for coming here and for their best wishes for this event. Have a nice day, everyone. Thank you.
Thank you very much, ma'am. I once again thanks.
Thank you, Desta. Now I have some announcement for our participants. I'm sharing the e-certificate generation link in the chat box. As we are using the free version of the Google, initially in the lockdown time, it was free. We can generate n number of certificates in a day. But now we have limitation that we can generate only 60 certificates in a particular day. Although in present list of our today's participants, 43 in count. So I wish you all can generate this certificate out of this link. But still, if you face any problem, if the link says that you're out of the range for today's quota, then I request you to please use the same link for tomorrow so that you can generate your certificate. I'm sharing this link in our chat box. You all can find this link in your chat box. By clicking on this, by giving the answers to your questions, you can generate your e-certificate. I think this link will work for you. It will work for you. So all are requested to generate this certificate. I'm again thankful to Dr. Nitu Katariya for being here.
Thank you, sir.
Thank you, ma'am, and all the participants.
This is a very good. I just want to give honest feedback over this FDP that it is a very valuable for the freshers as well as that who are working on this field. That our speakers have taken care of all the participants very well. That is the best of this FDP. That it is not as much as a high as that freshers cannot understand, not as much as the low that who are senior to there that feels that it's not of their.
Actually, when I was planning,
very nice that
when I planned this FDP, I was into this mindset only that whoever is joining this workshop should have idea and concept of polymer electrolytes, and they can utilize this talk into their research part. And I am also so happy to have all the wonderful speakers who actually share their basic ideas with the participants, and participants will surely benefited out of this. If still, I have a request from the participant sides. If they have any feedback on this FDP, they can share with us. Anyone? Anyway, again, it's an announcement that the link I have already shared with you. You can click on the link and you can generate your certificate. And if unfortunately this link never works for today, you can use the same link tomorrow for generating your certificate. And initially, my humble request is don't share this link with the others unless and until you generate your own certificate. Although I marked the email IDs in there, no other one can generate certificate by default. They have to be verified from my side, then only certificate can be generated. But still, thank you to all. I can see Dr. Vinod Kushwa after a long time. You can unmute, sir, if you want to say anything. You can unmute, sir. You are muted. Kushwa, sir.
Sir, please repeat, sir.
I'm asking if you have anything for us, please share with us.
Yes. In this present time, there is very good experience to attend this conference, FDP program, and some lecture has been missed. Some lecture has been missed in my side. So this is a very good experience to learn in the nature by the properties of material and some characterization properties for the application of different issues.
Right. Thank you. It's so long. We worked a lot with same institution, same department. I think we worked 10 years, more than 10 years. Wonderful days. I'm missing that again. Anyway, if anyone else, otherwise I will close the session and say bye to all for being here for last 9 days. It become a routine of mine to start my meeting at 11:30 and closing at 12:30. Tomorrow I will miss this link to get started. Okay, so today I am closing it. Thank you all. And if you face any problem by generating your certificates, and if you want any support from my side or any suggestions from me, you are highly welcome. You can contact me through the WhatsApp group that we have, or otherwise you can contact me through the email ID already shared with you in the FDP brochure. So till then, thank you very much. Take care, and we'll meet you soon on some offline mode. Thank you to all. Thank you, Nitu ma'am.
Thank you so much, sir. Thank you.
So I'm closing.
Sir,
Yes.
yeah.
Thank you.
Thank you.
Bye.
Leaving
So I'm closing it for today.
to all. Yeah.
Okay. Bye.